The bottle filler is a simple machine for filling milk in bottles in the modern dairy. In vacuum type bottle filling machine, filling on the machine is accomplished by creating vacuum in the bottle, and the bottle acts as a trap which fills with the liquid. No milk is drawn up with the filling tube unless a bottle is in the desired position. The height of filling is determined by the distance the vacuum tube extends into the bottle. This filler will not fill a broken bottle, thereby saving the milk. The major components in the bottle filling machine include the filler head assembly, overflow trap assembly, vacuum breaker, working table, filler head supports, and base support for the bottle. The filler head assembly is one of the critical components of the machine. It includes two parts, namely one is male part and other is the female part of the assembly. The gap of about 1 mm is maintained between the two concentric pipes of the male and female components, which allows the vacuum pump to suck air inside the bottle through acrylic cylinder and the vacuum breaker. As and when sufficient vacuum is created, the pressure difference allows the milk to flow into the bottle from the container. The design of acrylic cylinder assembly is one of the important aspects in this machine. A ready-made acrylic cylinder having 115 mm diameter and 200 mm height was cut. Accordingly, two circular plates were cut and holes were made with the help of a drilling machine as necessary. The cylinder was fitted with the help of a studs between the two plates. A vacuum gauge is mounted on the top of the plate of the assembly. One inlet and one outlet is provided on the top plate for the air to receive through filler head and led into vacuum breaker. The bottom plate is provided with one outlet that leads into the drain collector, wherein a non-return valve is provided. During the operation, after the bottle is completely filled, the milk is carried through the clearance of assembly into the acrylic cylinder. Under vacuum, the non-return valve enables the milk to retain in the cylinder. When the vacuum is released or reduced, the milk retained in the cylinder is led into the drain collector. Normally, as long as the vacuum exists in the system, the milk accumulated in the acrylic cylinder or the overflow trap assembly cannot be diverted to the milk container. As the acrylic cylinder is about to fill, the vacuum is broken with the help of this vacuum breaker. This allows the milk flow back into the drain collector without interrupting the operation of the vacuum pump. Now, we will try to understand the working principle of the bottle filling machine. Here you can see different components. The bottle filler assembly, the overflow trap assembly, the vacuum breaker, the vacuum pump, and the cans containing the milk. When the bottle is placed at the filler, vacuum is generated in the bottle through the circuit where the air is pumped by the vacuum pump. So the vacuum is initially created in the vacuum breaker and then in overflow trap assembly, and from there through the annular space the vacuum is created inside the bottle. Once the vacuum is created inside the bottle, the milk from the can is pumped into the bottle. When the bottle is filled, the milk passes through the annular space where the air is sucked into the overflow trap assembly. The overflow trap assembly acts as a buffer for the overflow of the milk. When the level of milk reaches to a certain extent, the milk is returned to the another can placed at the bottom. A non-return valve is placed where at a particular load of the milk, the valve opens and the milk passes into the drain can. This is how the milk going into the vacuum breaker is prevented, where if the vacuum breaker is also filled with the milk, it will further enters into the vacuum pump, which damages the vacuum pump. This is how the vacuum pump is protected at the overflow trap assembly.